I hope the thesis I'm going to present actually holds, because I'm not at my best, but I hope I'll be good enough. So you can get to the PDF of the talk at that URL, and you can always contact me at my Google.com address. One thing I always like to do is to introduce levels that I'm addressing. I think taxonomy is one of the great disasters of humanity, so having to classify as one of 3 levels is absolutely absurd. Because I cover a certain range of levels. Incidentally, the Shuhari trichotomy comes from the No theater. It was then applied to Aikido and other martial arts. There's the stage where you learn, the stage where you start detaching from the learning, and then there's a state where you transcend the learning. I believe the Western thought has a similar concept. It was presented at the pro-bad programming talk as a 5-level pyramid, trying to draw distinctions between stages of learning and detaching, but I think 3 are good enough. So that's what I'm going for. And if you've never thought at all about the nature of reality and technology, you may not get much out of our talk. At the other extreme, if you've thought about it for more decades than I do, then you'll probably be bored to death. But I hope I'm still addressing most people. So let's start by calibrating by show of hands. Who would roughly agree with this statement? Everybody should always be striving for perfection at all times. Any release that's not perfect is a waste of time. Do you mostly agree? Anybody? Show of hands? Few. The alternative, extreme, would be, let's keep it simple, just good enough, keep lunching, lunch early, lunch often, get feedback, listen, improve interactively, enhance, refactor, rinse, repeat. Who mostly subscribes to this philosophy? Great, I'm preaching to the choir, my favorite kind, so I presumably won't get much pushback. So I chose, although it wasn't really the first one, to choose the presentation, start the presentation from Richard Gabriel keynote at a Lisp conference in '89, titled "Worse is Better." It was intended as a humorous interlude in a very deep, serious technical conference, where Gabriel presented and contrasted what he called the New Jersey approach, also known as "Worse is Better," and the MIT Stanford approach, also known as the right thing. You can tell, no bias there. So after that, intended as a quip, short presentation, years, by now decades, of debate have followed, kindled by Mr. Gabriel himself, which posted on both sides of the issues, sometimes using the not exactly secret pseudonym of Nikki Ben Bourbaki. Let's frame the debate in the simplest terms. Everybody agrees that there are good characteristics of a system, say a software release. It doesn't have to be software, but software is mostly what he was talking about, what we're talking about. We all like simplicity, correctness, consistency, and completeness. 4 dimensions are a lot on which to optimize, so the distinction comes in with how do we exactly define each of the terms and what are the priorities when and if trade-offs are needed. In Worse is Better, simplicity focuses on implementation. Think of the then of Python. Import this at a Python prompt. I'll forgive you for pulling out notebooks if you don't really remember it. If it's simple to implement, it's a good. If it's complicated to implement, it's a bad thing. If it's simple to implement, it may be a good thing. That's one of the principles of Python. Also, of course, interface, but implementation simplicity is crucial because it lets you be reasonably assured you will not have bugs or fewer bugs and things. And simplicity is the most important consideration in your design. Correctness matters, but if you have to choose, rather be simple than correct. That's the worse is better. By the way, Gabriel never mentioned the magic word Unix, but New Jersey approach definitely pointed at the Bell Labs where Unix was emerging as the operating system to rule the world. The level of consistency required is to not be overly inconsistent, so it's not particularly demanding. And completeness can be sacrificed to any of the other three and must be sacrificed rather than compromising simplicity. Simplicity, simplicity, simplicity. The right thing, also known as the MIT or Stanford approach, focuses on simplicity of interface, correctness as the absolute must, the top priority of software development, completeness, important, roughly as important as simplicity. But you can see the priorities are not exactly the same and the definition of simplicity varies. So what's the trade-off between the two overall approaches? Well, the right thing philosophy is based on letting the experts do their expert thing, all the way to the end before users get their hands on it. He didn't say grubby, dirty little hands, but it's obviously implied in the phrasing. The experts know what's right and let them do it rather than having common people mess with it. The worse is better takes advantage, I'm quoting, so take advantage of natural advantages sounds a bit goofy, but I think it's good enough, and it's not my fault anyway. Incremental development and, grudgingly admitting, incremental improvement satisfies some human needs. Oh, gee darn. Shall we let the expert do their expert thing or satisfy human needs? What a difficult choice to make. I don't know if you're familiar at all with G.K. Chesterton, one of the great novelists of 20th century Britain. The Father Brown stories in particular are absolutely awesome. One of his quotes is, anything worth doing is worth doing badly, which kind of supports the in favor of bad programming thing. The point is worth doing badly because this way you reach some people earlier than if you wait until you're perfect, which will never happen, but if you keep striving for perfection, you'll never actually release. Incidentally, I had that during one of the presentations of this talk, somebody funny saying, oh, I see, so that's why you're using Comic Sans. Well, it's not as bad as that. I don't use Comic Sans. I use Apple Chalkboard. And you can debate whether Apple can do visual design at all. I think they have a good proven track record, so I'm going to stick with them. But that's not a part of the doing badly thing. Completely off from the side of this mainstream debate, Eric Raymond, the guy who's widely credited with coining or at least popularizing the term open source, in his 97 book and previously on the web and in conferences, showed two models of software development based on a different distinction, but they're pretty much aligned. The Cathedral and the Bazaar is also the title of his excellent book. Dated by now, but it still applies to the way people develop software. And you know, while software has changed a lot, people haven't that much. We're still on the 1.0 beta release, and upgrades are late in coming for human beings. So we'll have to deal with them, or with us rather. But so the Cathedral is close to the so-called right thing approach. Experts are in charge. They drive, control, they know what's right because, hey, they're experts. In the Bazaar, it's a chaotic launch and iterate, very New Jersey-like model. The crowd's in charge. So that's pretty much the New Jersey approach. The core Bazaar idea is actually focused on bugs. At least it's really a big part of the motivation for going chaos-like, Bazaar-like. Given enough eyeballs, all bugs are shallow. If even an expert can be staring at a piece of code which he knows isn't working right, even though he's designed the code himself. Actually, especially if he's been the designer, he may be too close to actually understand what the flip is going wrong, but give another 1,000 people the motivation and the ability to stare at the same piece of code, somebody will spot the bug, given enough eyeballs, or bugs are shallow. Now, some people may think this particular consideration doesn't apply to them because they never have any bugs. And if I'd only written one program in my lifetime, I probably would agree, because in 1974, I wrote my first ever program. I was a freshman, and two others, so a team of 3 people, 3 freshmen in hardware design. We wouldn't get any software course except the mandatory one in Fortran. So we got advantage of that to study up on Fortran on the reference manual. And then we were all bridge fanatics of the game of contract bridge. And we thought, hey, we could compute conditional probabilities of suit division given everything. Wouldn't that be cool? We had one chance to punch everything into punched cards, and then one chance to run it. Forget testing. There's no such thing, because that would require more than one run. It has to be right the first time. I think in the process, we reinvented approaches. More than pair programming, we did triplet programming, because while one guy was carefully digitizing, the other 2 had eyeballs staring at, you shouldn't type this, and so on. And that was my bug-free program. I think you either get one per lifetime or one per 40 years, in which case I'm due for another one soon, and but I'm not counting on it. So. There's more about it. If you think your goal is perfection from the start, you need what's known, especially in the agile community, as big design upfront, BDUF, BDUF. It sounds funny, and it's supposed to. You need big design upfront because this way, by the time you've actually got software running, it's going to be perfect, as it must be. Everything must proceed top-down. You perfectly identify all the requirements for your software before you've done anything about it. Then this gives you a perfect architecture from which follows a perfect design, from which follows a perfect implementation, and it takes forever and ever. Amen. So you got a problem with that. Real life doesn't cooperate. In particular, stakeholders, whoever is supposed to be using your program, or if it's a commercial endeavor, selling your program, kind of objects to the forever part. But to do it this way, it really does take forever. So what do you do instead? What do you do in the real world? Well, first of all, you realize that requirements change all the time. There is no way to capture once and for all every single requirement of your program, because by the time you're finishing even just the requirement analysis, the requirements are already changing from under your feet. Tempora mutantur et requirements mutamur in illis, to paraphrase a famous Latin verse. Then, architecture determines design, but design choices feed back to make you want to tweak your architecture. It's not a waterfall. There are all sort of loops back. And implementation always has some bugs. Well, always except for the once in 40 years case where it doesn't. But you're only going, no matter how careful you are in testing and specifying and so on, you're only going to discover your bugs when you deploy in the real world. There's a famous anecdote from the mailing list the risks of computers about an ambulance system that, since it was a life and death situation, understandably, was designed to never have a bug in the implementation. So it had a specification in a formal language. I think it was Vienna, could have been Z, one of the formal languages that were all the rage in the 80s. And the implementation was mathematically proven to respect the specification. It was launched. and mostly worked well. And once in a while, they got desperate people who had just called 911 or whatever the local number would have been, and for somebody having a heart attack, and the responder had promised an ambulance, and no ambulance ever showed up. It kept happening. So somebody went and checked. Surely we've specified against this. Well, one of the specifications is from the triggering moment, the ambulance must be on location for this kind of emergency within 15 minutes. So it's specified. Well, there's a problem with formal logic. If you say from A must follow B, then it means that not B must imply A. Given the ambulance is traveling on real streets with real traffic, you cannot actually guarantee 15 minutes. So say that given crazy traffic, the ambulance would normally get there in 15 minutes and 1 second. Well, when 15-minute trigger, the ambulance isn't there, so the logic in the system determines it must never have been called. That's logic for you. If it had been called, it would have been there in 15 minutes. It's 15 minutes, it's not there, so it can't have been called, so it gets rerouted. So obviously, being perfect in your specification and implementation doesn't actually work in the real world. Not if you're meeting any real world constraints, such as traffic. Traffic can completely, or maybe there's an accident or something, can completely block you. So the only way to go is iterative development. You must deploy something, find out the bugs, fix the bugs, missing features, add them, improve things, just solve some user problems. Don't even try to solve every user problem from the start, because you don't know what they are and they will be changing. So backwards incompatibility is your friend. We've heard Raymond, I don't know if he's around, explain that we can never afford it in the Python core. Well, fortunately we can. We could in the past. I sure hope we still can, because guess what? The original design wasn't perfect. We had mistakes, and we had to fix them in backwards incompatible way. And minor backwards incompatibilities kept happening on every release, just not too many at the same time. When a big bunch of backwards incompatibility became necessary, we moved from Python 2 to Python 3. The point is, if you're constrained to remain backwards compatible forever, you're host. You're really, really host. One little mistake you made 25 years ago will haunt you forever. You have to be able to fix your mistakes. Those early stage design errors. Good enough is good enough if and only if you can make it better later. One example, you used to be able to raise a string, which makes absolutely no sense, but was in the early design of Python. Now you can't anymore. If you try, the raise statement will inform you that you have a type error, because the only thing you can raise is an exception, not a string, which makes much more sense. So that's backwards incompatible. This particular incompatibility was introduced in 2.6 in the hope that nobody was still raising strings instead of exceptions after all these years. Another way to think about it is think of perfect as a verb, not as an adjective. Perfecting your work is great. Keep doing it. Keep perfecting, as in improving and moving towards a better release. And the only way you can do it productively is to have real data. If nobody's using your program, you don't really know much about it. So you need to be out. You need to have a release. And real people using it, if you can find any real people. Perfection is a process. It's never a state. You never reach perfection. You keep moving towards it, and as you do, the goalposts keep shifting, because people need change. Even when, just by using your software, they realize some needs, some desires they didn't realize before your software was solving some problems, because solving certain problems uncovers others, which is why you keep improving and releasing. There's never any laurels to rest on. So take that into account and release early, release often. This doesn't mean you just hack something together with no care for any aspects of quality. There are things you do not want to skimp on, ever. First of all, some lightweight process. Just hacking with no rhyme or reason for half an hour when you have nothing better to do or are finding some excuse to procrastinate on other stuff is not good. You need a lightweight process. I'm not recommending something that holds you rigidly like an armor or something, just some lightweight process with well-defined steps. And the number one thing you should never be without is a revision control system. I mean it. I keep getting, now that I lead a support group, I keep getting people saying, okay, so I uploaded this program to your cloud, and I need to make a fix, but I've lost the source code. Can I download the source code again? Like, you what? You lost the source code? Don't you have it in, I don't care, Subversion, Git, Mercurial, which revision control system is a second order problem. You must have some so that you can know what was going on before and you can check it out and improve and check in the revised version. Unless you're all alone, and even then, code reviews are the second most important things in software development. You shouldn't skimp on them. I've had, in the past, the experience of developing relatively complicated pieces of code on my own because I just couldn't get anybody else interested in both the subject area, contract bridge, and the development to do code reviews for me. So what I did code reviews for myself. Specifically, I furnished myself with a rubber ducky, very recommended accessory for any software development. And after I'd finished a module or improved a function or something, I put the rubber ducky next to me and explained to the rubber ducky exactly what I had been doing, as in an interactive code review process. You know what? It helps. I'm not going to say the rubber ducky spotted problems, but maybe it did, but in this case it was keeping its quiet. But as I explained what I had been doing and why, sometimes, so I spotted the problem, which I wasn't spotting when actually coding it, because I don't know, I guess, I'm no psychologist, but there must be slightly different mental mechanisms involved in doing something versus explaining it. So the explaining part is, if you can't get a real code review, the next best thing, and you shouldn't do without it, even if you have to develop something all on your own, review it with your rubber ducky. I'm sure somebody will prefer teddy bears or so on. That's a technology discussion that we can have separately, but some appropriate soft toy. I think it should be soft. If you try to explain the thing to that beautiful Python toy, which isn't soft, is probably gonna stare at you coldly and you'll, well, anyway, sorry. And third, absolutely crucial thing, possibly on a par with the other two, is testing. I've heard that one thesis I've heard in the bad software talk, which I strongly disagree with, is that sometimes you can skip testing. I have never found a case where that was the case. It actually doesn't take you extra time, it saves you time, because the earlier you find a bug, the faster by far it is to fix, besides having done no damage at all. if you don't have tests, all the bugs will be found by end users, possibly losing their data or sending their credit card on the open net or other pleasant experiences. You don't really want to apply that. They also very important, but possibly hardest for all of us because it's never really taught properly, is to follow proper release engineering procedures. Which include the ability to reconstruct exactly what software was running when you have a bug report. Because say, I do this and that happens, and you try on the current release of the software and no, it doesn't, that doesn't mean that whoever told you about the bug is batshit crazy. It means it's running in slightly different environment than you are. You need to be able to reproduce the bug to have any chance of diagnosing and fixing it. So you need to be able to reconstruct exactly what bits were being run on what environment. And exactly how you go about it, that's a whole talk on their own. And I'd probably get 1/10 the audience because it's not the most exciting and interesting part of software, but it's really a must if you want your software to actually help people, proper release engineering. Next, style, clarity, elegance. You may think you're saving time by being sloppy and naming all your variables I, J, K, L, M, N, O, P. Not really. It's not going to help you the first time you have to go back and say, what was I thinking here? Because if that's the kind of way you were programming, you probably weren't thinking, so it's kind of hard to. Elegance. There's a reason we appreciate elegance. It bespeaks of solid structure, so never sacrifice that. Last but not least, if that program is going to be used by anybody by yourself, and even if you're going to be the only user, document what you're doing. It doesn't have to be anything fancy, but at least good doc strings with doc tests inside them, clear comments as to why you're doing something, and my colleague Thompson's famous comment in the original Unix sources, comment being, you are not supposed to understand this, is not the kind of thing I believe. I mean, it's fair enough. It's too clever for normal human beings. On the other hand, in the Python community, clever is not a compliment. So don't, if you find yourself wanting to write that, try to be a little bit less clever. You'll be grateful to follow that advice. In other words, the fact that good enough is no excuse for cowboy coding. It's just to take, coding is still a labor of love, and you want to follow the main principles that I've outlined. Next, some things, some characteristic of your software, depending on what that software is, must be in from the start. Believe me, I've seen 1,000 examples, I'm only slightly exaggerating, where the issues were not properly thought of from the first, and people tried adding them later, and it doesn't work. And the main one is security. If there's any possibility that your program, your system, is going to be handle data which is at all in need of security, including privacy, including auditability, think about that from the beginning, even as you sketch the first prototype. Why? Well, I think the core idea is when you're doing security or its appendices such as auditability and privacy, you're mentally fighting against an adversary. Would-be black hat who'd like to get at, I don't know, financial data, health data, whatever it is that you need to keep secure and private and auditable. Maybe they'd like to skim some money off people's accounts and hide it so audits won't show it. So you're going to be in a difficult position anyway, because you are going to be fighting against an adversary you don't really know and who might well be as clever or more than you are, and is single-minded focusing on exploiting any weakness in your software. That's what makes security such a difficult problem. There's so many vectors of attack. Therefore, the very least you can do is think about it from the start. Believe me, if you have a successful program which is just about perfect, except that anybody can hack in and just get all the data about, I don't know, all the appointments this person has, thereby deducing something about their professional activity or whatever it is the appointments are going to do in break their privacy and so on, you are going to regret it. Your attempts to fix it after the fact by working security in that wasn't there from the beginning are more than likely going to fail to a strong, determined adversary. Many other things would be nice to have from the start, but you can refactor later because you're not actually fighting actively against an adversary. So you can refactor to get modularity, accept plugins, have an API. I love APIs. I think every good piece of software should have one, but it doesn't need to be in the 0.1 alpha release. Hit the street with something that works and then refactor the API. Scalability is crucial. Hey, I work at Google. We think that your application has only 1 billion users. Count yourself lucky. It's easier to scale that to that little. But it doesn't have to happen in the 0.1 alpha release. You can, it's easier if you're thinking of it from the start, but you can, because nobody's actually, well, you could get a denial of service attack, but that's a different issue. You can still, essentially, to summarize, you can incur technical debt. I don't know if you're any familiar with the term technical debt. Is stuff that's slightly wrong with my system. I know it's wrong, but I need to release or I need to add a feature, so I incur debt. The point is not ignore it. Do it with care. Do it deliberately and plan your repayment. You don't want to leave the technical debt hanging around forever. Another perpendicular way of looking at it, okay, so I may have an error. Is the error going to be recoverable? Focus on avoiding errors that could provide irrecoverable losses. That's why all my sympathy goes to the people who are designing and implementing that ambulance system, because an error in ambulance routing, as unfortunately happened, can cost somebody's life and you have no way to bring them back to life. That's an irrecoverable error. On a slightly lower plane, if an error can send you into bankruptcy, well, it's technically irrecoverable. You can live after that, but it's getting pretty close to where you don't want to risk it. But as long as you can recover, you're okay. Just call your release beta. Hey, we're pretty good at that. And beta say, oh, sorry, I'm sorry there was this bug, but it was a beta, you know, so we tend to do that. One bit that people tend to trip on, especially ones who are hidden perfectionists, as despite the show of hands, I suspect a lot of us are, is what about reputational damage? I mean, if my program has a bug, news about it will spread, people will think I'm a bad person, a bad programmer, they won't love me anymore, and I'll be sad and alone. Reputational damage. It depends, but usually reputational damage is recoverable, especially if you don't close yourself in doing the next release and ignore your bug tracker, issue tracker, or whatever you have, and have something when you release a piece of open source software, or a commercial one, of course. If you do courteous, speedy response, if you offer service to go with your program, get it right the second time is usually okay. I now say, wait, what? I've written a piece of open source software, I'm donating it to the world, and I also have to listen to those whiners saying that it's missing this and it breaks that, and oh, forget it. No, get the right, okay, now I wrote this originally before I took my current role in technical support, but it was true even before I did. Now that I am in technical support, of course, I see service as absolutely crucial. There's a secret to customer service, not that secret. There's even books about it, as I am indicating one. The specific study in sagepub.com was specifically about hotels, but there have been other studies for other industries, and it kind of generalizes. The customers with the highest level of satisfaction, the one who are most likely to plan a return trip, recommend the hotel or other product and service to their friends and so on, are those who have had a problem during their stay in the hotel. It was resolved courteously and promptly and effectively. They are happier and more satisfied than those who had never had any problem at all. It is a paradox. It's called the service recovery paradox. And suddenly I'm tempted, oh my God, I could put in 3 or 4 bugs that I know about, so I'll be very, very, but I think that's evil, and don't be evil is. So I've resisted that temptation. But you have to admit, it's like when you know that no matter what you release, your manager will be back to you and saying, it's okay, but make it faster, having some do-nothing loops here and there which you can surgically remove, and voila, your software is faster. It's the same kind of temptation. Avoid it, because it's not the proper professional behavior. Still, this is worth thinking of. In the pursuit of fast release. Does that mean we should always do ad hoc point solutions and never any general ones? That's what the intuition tells us is going to be faster, right? Well, not always, especially not in Python, where a little bit of metaprogramming goes a long way. This is a very simple example. We have a bunch of things in some kind of tree or graph under root, and we want to find and yield all that are of a certain color, say their shapes, or all that are of a certain shape, all squares or circles and so on. So writing this and this, almost identical functions, except that one is called checking root.color, the other one is checking root.shape, doesn't really take any less time than doing it right from the first. It violates the dry imperative, DRY, don't repeat yourself. This isn't literal repetition, but as close as it gets. So just generalize and take name and value as argument and use getter to get the appropriate attribute. And next time, and I also need to find by height or other characteristics, you've already solved the problem. In worse is better versus the right thing, I now want to offer some example. Well, first of all, we've given up one of the great advantages of compiled languages used to have, like C++, which was my code's compiling being the perfect excuse to slack off for a bit, which with Python or actually modern languages like Go, which compile and link in a flash, we've lost that. But obviously, we think it was worth it. A more serious example. How to model a network? Well, there's TCP/IP with its rough consensus system, and there's the ISO-OSI model, which thousands of experts spent decades debating to make perfect. Rough consensus and running code have always been the principle of the internet, of TCP/IP. And the phrase is due to David Clark, who actually was at MIT and worked on the project Multics that Gabriel no doubt had in mind when he contrasted New Jersey versus the right thing. But it was also in the internet engineering task force for all it was worth. Guess what? My daughter recently got her PhD in telecom engineering, and she explains that, yeah, the first couple years courses are all ISO to the core, and then you start getting past your bachelor and into the real world of a telecom engineer work, and everything becomes TCP/IP, because except for a few big telecom apps where you probably wouldn't want to work anyway, the world is TCP/IP. Everything is. So simplicity and being there won. Similarly, hypertext. Hypertext was hinted at even by Vannevar Bush back in the 40s, as we may think, great work, which I strongly recommend reading, but essentially hit in the 70s with the Xanadu system, computer lib. That was the name of the book. You can, I think, find it online, also known as Dream Machines, explaining how perfect hypertext should work. And 10 years later and 20 years later, nothing had been released to make it real. Not because the guy had stopped working on it. I've even had a friend who was a head system administrator for, I think it was called Xanadu Inc. They were just not releasing anything because it wasn't quite perfect yet. One chemical physicist at CERN decided he wanted some hypertext to make it easier to share research results rather than going through the obviously old-fashioned by the 90s paper route. And he hacked together something. He wasn't a software developer. He just invented essentially HTML and HTTP and the concept of a browser, showed it at a conference, and started releasing this very flawed, full system, full of defects. Just imagine, links are one way, meaning asking who's linking to me requires you to essentially get a copy of all the web to analyze. That's what search engines do, but it's absurd. Why aren't linked two ways? What if you want to link to one paragraph out of a long article? You cannot. There is no way. HTML and just doesn't let you do that, and so on. I could go on for an hour decrying what a horrible design for hypertext the World Wide Web was from the start, and despite 20 years of improvement, it still kind of sucks. However, guess which system conquered the world and is running the world? The perfect one that actually never was released because it wasn't quite perfect yet, or the broken, barely functional one that met some human needs, satisfied some real problems? The question answers itself. An example Gabriel actually gave, what if a long-running system call gets interrupted? Well, in the ITS, and I believe in Multics by design, every long-running system call had to be interruptible and as atomic as feasible, meaning every system call must be able to get the interrupt, know there is an interrupt, unwind any state changes that have been done so far, resume user mode so that the interrupt can be serviced, restart kernel mode and either redo all the original work or restore state as saved in the first point. That meant writing, for example, a device driver extremely hard. I imagine, I've never done so, particularly because it had all to be assembly language. In early Unix, if a system call gets interrupted, it sets the global variable erno to Intr, the constant Intr, and returns -1. That's it. It's up to the application code, which is not responsible for that interrupt, But the application code must know to check for the "I've been interrupted" error and just redo the call, which is, if you think about it, architecturally broken, but it works and it's extremely simple, and writing a device driver for Unix is a walk in the park. It's simple, it works. And yeah, it violates boundaries of perfect architecture, who cares? I'm going to skip the Metaclass versus Decorators because I always get a lot of pushback on this one. And the evolution of sorting in Python, all the way from the original where you had to pass a comparison function unless you were doing natural comparisons, and it was always in place, through the decorate, sort, and undecorate, and then they sorted. Similarly, other things. Generators started out as yield only because that was simpler. Then they became two-way with send. Finalization started with the goofy try finally. Then the with was introduced. The point is you can almost always make things better. So to find out what does better mean, go ahead, release something. I needed, unfortunately, to censor xkcd to avoid violating the code of conduct, but I recommend you go for the original since xkcd doesn't have to obey a code of conduct. Let's branch out from sitting at a computer developing software and have some adventure. For example, what about making a firm? Eric Ries, in the concept of lean startup. The title being good enough never is, or is it? As it is gonna be if you hit just the middle way to make the minimum viable product. That has not, it could be software, but it could be anything. Any kind of startup making a product should have something out on the market that is the minimum viable one, meaning some people will use it, meaning it solves some human need. So you will get validated learning, as you put it, feedback, another way of putting. Of course, I have to point out that Hanson of 37 Signal disagrees and says, why these complications? Just build something awesome and ship it. If you can do that, congratulations, but we're not all 37 Signals level people. Another idea, everybody wants the perfect employee, except it's a very broken idea. If you are holding out for the perfect employee, you will delay by months, you will miss market opportunities. Assuming there is a person who would be your perfect employee might well not be out there looking. They might have a perfectly satisfactory job. You'll probably end up over budget. It costs to recruit and hire people. Rather, pick a good fit, not a perfect fit. Sure, you're using 12 fancy technologies, and this candidate only knows 4 of them and has heard of another 2 and never heard of any of the other 6. Does it really matter? We're all pretty fast learners. As long as the personality matches your culture, your startup culture, hire that person and let them learn on the job what they need to. Learning on the job is quite effective. All I got in college was hardware. Everything I know about software management, entrepreneurship, I taught myself on the job. Well, I taught myself and got taught by colleagues. It's not the only way. Then a reference from the fantastic word of merchandising. This book, The Paradox of Choice, is definitely recommended. Essentially, people fall with intermediate variance into 2 categories. For the maximizer, 99.99% is not 100. Mm-hmm. Oh, okay. I thought it was 12:15. Sorry. Anyway, the Satisficer is, for example, the follower of Pareto law, which knows that 20% of the effort gives you 80% of the result. Then there's a Gettysburg Dedication. It was officially given by this guy. You probably never heard of, Edward Everett, even though he was governor of Massachusetts, a senator, blah, blah, blah. He carefully penned 13,000, I haven't actually counted them, but I trust people who tell me that, and spoke for 2 hours based on reams of paper. The president was always also visiting and gave a very, very short address, 267 words. He's been reported to have looked at a crumpled envelope in his pocket, which he may have written on the train there. 2 minutes, 267 words. Not all of them true, because one sentence from those is the word will little note nor long remember what we say here, and yet we still study that in our schools. So, just to finish, I'm trying to lower your expectations for what you can do. Absolutely not. Your dreams must stay big. As somebody put it, I wonder if anybody recognizes the quote, rightly traced and well ordered, what of that? Speak up they please, what does the mountain care? This is an artist who's been praised for rightly tracing and well ordering his painting, and is disgusted at being praised that way. What he wants to do is grasp people's hearts, make a difference in the world, not properly trace lines. My point is not that you shouldn't aim to change the world and grasp people's heart. It is that the best way to those dreams is to release early and often, to learn from real user interactions and keep making things better, and keep ambitious, hungry goals. But a man's reach should exceed his grasp, or what's a heaven for? And of course, the quotes, in case you hadn't recognized it, are from Browning's Andrea del Sarto, who also has, nobody remembers that, but the first written occurrence in English of less is more. And with that, I guess we don't have time for Q&A if they curtailed my length. This is, again, the URL. This URL takes you to the early release of the 3rd edition of Python in a nutshell. Ebooks only, but in all formats and DRM-free. And if you buy it today, you will get about monthly refreshes so that you'll be all the way to final release. You'll have the 3rd edition of Python in a nutshell on all of your devices. And at checkout, use this code, stands for author discount, you get 50% off. And the reason I'm really keen to do that is not to sell a few more copies, is to get feedback. Remember my address, aliax@google.com. I welcome feedback on the book. And now is the best time to give it, because if you wait until it's finalized to production and put on paper, the amount of improvements I can do is tiny. Right now, if you convince me a chapter should be split, added, removed, completely reorganized, I can still do it for the next couple months. If you don't send me feedback, I will not know that this wasn't good enough. And that's it.